R.D. Sharma Solutions, we are taking class 11th, chapter 13, complex number exercises 13.3. Here we have to find out the square roots of a complex number. So if we have this a plus ib, we have to find out the under root or square root of this complex number. Let it be x plus iy. Now in my discussion earlier, when I discussed about the concepts, I tried to prove it, derived this formula. So you must revisit those formula. So I'm just writing it here directly. That under root of this, let us say that this is z. Under root of z will be equal to plus minus the half, then mod z plus real part of z, right? And then plus I under root half mod of z, that is the modulus of z, minus real part of z. And this is true when the imaginary part is greater than 0. But if the imaginary part is less than 0, so we will take a minus here. Same formula with minus. So this is what we are going to apply everywhere. When we have z equal to minus 5 plus 12i, in this your a, or you can say x, is minus 5 and your b or y is 12. That is, the real part is minus 5, the imaginary part is 12. Now imaginary part is greater than 0, so we'll use the plus formula. First of all, we have to find out the mod z. Mod z is what? Mod z is the modulus. So you take the real part and imaginary part, square them, add them, take the under root. So it comes 13. And we have to use the plus here, not negative, because it is imaginary part is greater than 0, imaginary part is 12, which is indeed greater than 0. So we'll apply it here. Just put this mod z here, which we just found, and then plus imaginary part, then plus the again mod z by 2, and this is the subtraction with the real part. So this is what you get. 2 4s are 8, so you get under root 4 2, and here 2 9s are 18, under root 3. And you have to use this plus minus sign. This is outside. So same formula we are going to apply here. This is your x, this is your y, or imaginary part, and real part and imaginary part. Now real part is minus 7, imaginary part is minus 24. Since imaginary part is less than 0, if this is x plus iy, y is less than 0. So what we will do, we'll use the negative formula. That is the minus formula here. Plus minus remains, everything remains same, only this plus will become minus. Now mod z is this minus 7 whole square plus minus 24 whole square. Take the under root, you get 25. Put it here in the formula. You get plus minus 3 minus 4i. Similarly with 1 minus I, this is 1, that is real part is 1. Imaginary part is minus 1. So the imaginary part is less than 0. That means imaginary part is less than 0. That means what? You have to take a negative formula. Now what is the mod of z? This is 1, this is 1. So 1 square plus 1 square, that is 1. Actually this is minus 1. So 1 and minus 1. So 1 square plus minus 1 whole square under root, that is going to be root 2. Just put it in this formula, and this will remain like this because this is under root 2. We have minus 8 minus 6i, so the real part is minus 8 and the imaginary part is minus 6. So imaginary part is less than 0, that is y is less than 0. Take minus 8 whole square plus minus 6 whole square, take the under root, you get under root 100, which is 10. Now here just use the formula with the negative sign. So whatever you get, this is the simplification. 8 minus 15i, real part 8, imaginary part minus 15, since it is negative, less than 0, so we'll use a negative form. And this mod z you have to find out, 8 square plus minus 15 whole square under root is going to come 17. Put it in the formula as I discussed earlier, and just you can take this when you simplify it, you can take this root 2 outside, 1 by root 2 like this. Then you have z equal to minus 11 minus 60 under root minus 1. So minus 11 minus 60 under root 1, I square is minus 1. So I is under root minus 1. So this is I. Now the real part is minus 11. imaginary part is minus 60. Since this is less than 0, so we'll use this negative formula. For that we have to use this mod z, minus 11 square plus minus 60 whole square. You get 61 under root after finding the under root. And then use this plus minus. This is mod z minus real part, mod z plus real part, and just simplify it. Here you have 1 plus 4 under root minus 3. So 1 plus 4 under root minus 3 can be written as under root minus 1 into under root 3. So 1 plus 4 under root 3, I, this under root minus 1 is I. So you have 1 plus I into 4 root 3. So here the real part is 1, imaginary part is 4 root 3. You can say x is this one, y is this one. So x square plus y square under root is your mod z, 1 square plus 4 root 3 whole square. Under root is 7. And then you can just put this mod z here, and since this imaginary part is greater than 0, so we'll use a plus formula and we get this solution. Here we have z equal to 4i. You can write it as 0 plus 4i. So real part is 0 and imaginary part is 4. So first we will find out the mod z, which is 0 square plus 4 square. So it is actually 4 square, you get 4. So this is 4 is mod z. And then we have this, this is 4. Now here, if you see, since the imaginary part is greater than 0, we'll use a plus formula. So you get, just simplify it, take the root 2 outside also, 1 plus I you get. Now you have z equal to minus I. So we can write it as 0 minus I. So real part is 0, imaginary part is minus 1. So it is less than 0, so we'll use a negative of this one, negative in this formula. And what will be the mod z? It is 0 square plus 1 square, or 0 square plus minus 1 whole square under root. 0 plus 1 under root, that is going to be 1. So 1 will come. Mod z is 1. Just put it in this formula and take the root 2 outside. It will be like this. So this is the exercise pertaining to the square root of the complex number. Thank you so much. Take care of yourself.